I think it's time to start. We have a very packed agenda today. So, good morning from wherever you're joining us. I see France, Germany. Welcome to this Data Europa Academy webinar. My name is Flora Copello. I will be the moderator of today's sessions. I work for the Publications Office of the EU on data.europa.eu, the official portal for European data. For those that are joining for the first time, this is the third webinar on a series of webinars focusing on the data spaces. Data spaces are a key element of the European data strategy. They're bringing together relevant data infrastructures and government frameworks, and they allow for the facilitation of data pooling and data sharing. Following the importance on this topic, the Data Europe Academy has initiated this webinar series on data spaces, and throughout these sessions we would like to make sure that our audience, everyone joining, is getting a clear understanding about data spaces and their overall importance for the European data economy. So before diving deeper into today's topic with the help of our of today's guests and experts, maybe a short recap of what we have seen and what we have discussed so far throughout the previous webinars. Our first session took place in May and introduced the concept of data spaces and the policy and legal framework behind it. The second webinar took place a few weeks ago, September 15th, where we provided concrete examples of the health and cultural heritage data spaces. Two experts shed light on how these spaces contributed to the European data strategy and provided insights into their future. And today's webinar will focus more on the operational and technical building blocks of data spaces, explaining the technical and operational aspects of them and the support mechanism and tools that are in place when building a data space. So I will not take more of your time. Moving on, and before we go to today's agenda and to introducing our speakers, I would like to take a moment and share with you the rules of today's webinar. This webinar, as every other Data Europe Academy webinar, will be recorded, and the recording and the presentation will both be uploaded and be available in Data Europe Academy and be shared with you on a follow-up mail. So you will all receive this information very shortly. Regarding the questions, please feel free to use Click Meeting chat throughout the session. We will make sure, our experts will make sure either to answer throughout the session, or we will have a dedicated Q&A time in the end of the webinar to answer to all of them. And in case we don't have enough time to answer these questions, we will make sure to have a report sent out to you. And lastly, please do reserve 3 minutes after this webinar to answer a survey. This is so beneficial for us in order to make to further improve our content and webinars in general. And as previously mentioned, today I'm not alone. I have the chance, I'm very lucky to have experts with diverse backgrounds on data spaces that will touch upon the different aspects. Starting with Clara Pezuela. Clara has a degree in computer science from the Universidad Politécnica of Madrid. She has 23 years of experience in research for digital technologies domain, mostly through European research and innovation projects. Currently, she's the Vice President of Funded Programs at Fireware Foundation, and she has an advanced level of knowledge in data architectures, cloud, edge, Internet of Things computing, data platforms, and data spaces. And currently, she's working on the Data Spaces Support Center, and it's involved in some domain data spaces, such as smart cities and communities and manufacturing. Thank you so much, Clara, for being today with us. Then we also have Edward Curry with us. Edward is the established professor of data science and director of the Inside SFI Research Center for Data Analytics at the University of Galway. Edward has made substantial contributions to semantic technologies, incremental data management, event processing, middleware, software engineering, as well as distributed systems and information systems. The excellence and impact of his research has been acknowledged by numerous awards, including Best Paper Awards from the University of Galway, President's Award for Societal Impact. He's also the organizer, program co-chair of major international conferences, including the European Big Data Value Forum and more. Edward is also the co-founder and elected vice president of the Big Data Value Association, which is an industry-led European big data community. So thank you very much, Edward, for being today with us. And lastly, we also have Alexandra Balahur. Alexandra is an experienced program manager at the DG of the European Commission at the Interoperability Unit. So thanks all three of you for taking the time of being today with us. I'm looking forward to hear everyone's interventions today. And as mentioned, we have a very packed agenda. So just to brief you before starting and kicking off with today's content, we started already with the opening and the introduction of the series. Following this, Clara will provide us with a full overview of the building blocks of the data spaces for 20 minutes. Then Edward will have 20 minutes to give us information regarding the research challenges with data spaces. And lastly, we will have Alexandra to give us more information during 20 minutes on the SEMIC specifications, services, and trainings in support of data spaces. Following this, we will have the Q&A session. We will open then the floor to you, where you can ask any questions you may have regarding the operational and technical aspects of data spaces. As in the previous editions, and as I mentioned before, in case we don't have enough time to answer all of the questions, we will make sure to have a report replying to any questions you might have. So, and without further ado, because we have a lot to go through today, Clara, the floor is yours.
Okay, thank you very much, Flora, for the introduction, and thanks for the invitation to be here. Today, on behalf of the Data Spaces Support Center, as I will describe later on, is the project in charge of coordinating and supporting the Common European Data Spaces. And without no more delay, I'm going to go through the presentation. So I know that this is the third webinar you have about data spaces. So I'm not going into very much detail about definitions and the concept of data spaces, but I would like to bring here, which is the view of the support center regarding the context of the data spaces. So the main message of this slide is that data spaces are not built from scratch, are a specific case for data sharing, and data sharing is relying on data, and the data spaces are using and being supported by digital ecosystems that already exist. So nothing is new from scratch. So it's a matter to leverage on what we already have, and of course to support the implementation of the European data strategy and becoming really concrete through use cases. So bear in mind this context, what the support center is defining as a data space, according to the glossary that I will explain later a bit. It's a distributed infrastructure governed by a governance framework in order to elaborate on the rules and the roles of the different participants in the data space that is able to enable trusted data transactions, guaranteeing the data sovereignty. So this is in contraposition to what is usually a data lake or beyond a data platform, and of course much more beyond of simply a digital ecosystem. So in this context, the Data Space Support Center is this initiative that has a mission to support the data spaces in having a quick start and accelerated deployment in order to allow them to focus on the specific benefit for the participant by providing the set of tools, of instruments in order to set up and to deploy these data spaces. So I will detail right now which are these instruments, these tools that the support center is putting in place, but I would like to highlight that all these elements has been co-created with all the data spaces that are around, and I will detail later on how. So just to give you an overview of the different assets that the support center have been already provided and is going to provide, here just this brief schema. We have already provided a starter kit that is a kind of guide for beginners in the data spaces, and we have just released the first version of the blueprint that I will detail right now. Apart from these basic assets, we are also providing a support platform in order to provide a channel for everyone that is building or setting up a data space to consult to the experts to the project and also to get involved in the co-creation of these assets. We have created a network around the project, which is formed by the data spaces that are emerging, but also by relevant stakeholders that have been working in data sharing and in data since a long time ago. Annually, we are organizing also a conference, so you are invited for the next one that will take place in March next year. Additionally, we will have also other results like a radar, a maturity model, or a taxonomy for data spaces that will be delivered in short. So let's then focus on the blueprint, which is the asset that contains the building blocks, which is the topic for the talk today. So as I said, the blueprint has just released by the end of September. You can visit the website of the project, dsc.eu, and you can see there at the knowledge base the different elements that we have already released. And in that, you will see the blueprint itself. So let's go through the blueprint, and then let's go one by one through the different building blocks. So just to define what the blueprint means for the support center is the set of guidelines and tools to support the data spaces in the setting up and the deployment. So what are the elements that are included in the blueprint? So first, we have a glossary, which is a set of curated terms and definitions that allows us to speak the same language through all our communications and publications. Then we have the conceptual model, which is a model with the concepts defined in the glossary and the relationships amongst these concepts. And then we have the building blocks, which are these basic units or basic components that provide the capabilities, the functionalities that a data space should have, and how all combined can provide the overall organizational and technical capability of the data space. These building blocks can be defined through different elements as well, like functional descriptions, technical specifications. And in order to implement these building blocks, we will be providing also recommended standards, reference implementations, and best practices. As you can see in green, the boxes that have been released right now in the version 0.5 of the blueprint at the end of September. And in orange, you see the elements that will be included for the upcoming version in April next year. So let's then go to the different elements. As you have seen in this version, we have provided these three elements: the glossary, the conceptual model, and the building blocks. And here you have the direct links to the website in order to learn more about that. But let me go one by one, and I give you some hints about the different elements. So let's start by the glossary. As I said, the glossary is this common vocabulary that we are using in the support center publications and communication, has been co-created, co-developed with other data spaces, and it includes terms with definitions and with criteria in order to define this term. We are aware that we cannot impose this vocabulary, and we, of course, respect others' terminologies and other vocabularies that other data spaces may be using, because we understand that the same term may have different meanings in different contexts. As much as possible, we have adopted all the definitions that are provided already by the European legislation and international standards. And the glossary has been divided in sections where you can see from the core concepts of a data space to the different level maturities of the data space. Also in terms in relation to the legislation, terms in relation to interoperability, to identity, and so on. So through the website, you can navigate through the glossary, and you can see the different definitions. Of course, this is an evolving asset. We will be incorporating new terms with the timing being in the following versions of the glossary. Then the next element in the blueprint is the conceptual model. As I said before, is represent the concepts and the relationships among the concepts. And we have split the conceptual model in 3 different levels. In this version of the blueprint, we have released only the level 1, which is including the basic terminology and key concepts of a data space. So here you can see how the data space is related with other contexts. A data space is enabling data transactions that are linked to data products that have been implemented by data spaces use cases, and the data transactions are between the different data space participants. On the other hand, the participant has to commit to a certain governance framework that has been materialized by a governance authority that has defined different roles in a data space. And finally, the data space infrastructure is the one in charge of implementing the data space. So you can see here all the relationships in this level 1. In the future versions, we will provide the level 0, which is the environment of the data space, so what is happening around a data space, and the level 2, which go into more details of each of these specific concepts. And the third element of the blueprint that is included is the building blocks. The building blocks are these basic elements, basic units that are essential to bring the capabilities, organizational and technical capabilities of a data space. For that, we have split this taxonomy of building blocks in 2 main sections. One focused on business, governance, and legal aspects of the data space, and the another one on the technical side, which have been classified about data interoperability, data sovereignty and trust, and data value creation. So let's go one by one, just to give you some small hints, because we don't have time to go deeper into that, but you have all the information in the website, so you can navigate through all these building blocks and you can get all the information there. But let me give you some brief hints for each of them. So in the case of the business building block, here the idea is to provide to the data space with essential concepts about business modeling. This implies mechanisms for creating the business model in the data space, for fostering creation of use cases, for templates for defining data products, and also explain how to make decisions around data space intermediaries. It's important here to distinguish between the business model of the overall data space and the particular and specific business models of the data space participants that can be very diverse. So the next one is the governance building block. In this case, what we are providing is a couple of building blocks that are dealing with the governance of the data space. On one side, we have all the rules and roles that has to be defined by the data space governance authority in order to set up this governance. And the another one is the building block for helping in the governance of the data sharing, how these rules are applied to the data sharing in the data space. This governance has to evolve with the time being, with and to be adapted to the different needs of the upcoming participants, and also requires an overall agreement of all the participants. So it has to be work together amongst all the participants. And the third category within the organizational and business building blocks is the legal part. Here we are proposing 2 building blocks in order to understand which is in order to facilitate the awareness of the legal framework around the data space. So it's important for the data space to understand which is the legislation that is affecting to them and how they can be compliant with this legislation. So that's why we are proposing one building block focused on the awareness of this legal landscape, and another building block more focused on creating the contractual framework that the data spaces can use in order to regulate the obligations and participation of the data space participants. Then let's move to the technical building blocks. For the technical building blocks, what I have done is for each of the 3 categories that I have mentioned before, to explain briefly in this table, which is the elementary description for each of the building blocks, the key capabilities that each building block is bringing to the data space, and the link to the specifications to more details about how this building block can be used and built in order to allow you to know more about that. So in regards to data interoperability, which is at the core of data space, of course, we have 3 building blocks. One focus on the data models or the capabilities to define how to share data in the data space. How we need, in order to share data in a data space, we need to speak the same language. We need to use same vocabulary, we need to manage these vocabularies, and we need to get access to these vocabularies. So this building block is about these capabilities. The data exchange building block is more focused on the actual exchange of data. So it's how the participant A is able to share data with participant B of the data space, and then is proposing a data exchange API in order to facilitate this exchange of data, and all the specifications and best practices in order to adopt this API, and tooling also for managing this API. And the third building block is about provenance and traceability. These represent the capabilities for tracking the process of the data across the data space, and to provide evidences about the usage and the manage of this data across the different participants in the data space. So in the second category, of building blocks, we are talking about this data sovereignty and trust. And here we are tackling, for example, with a building block about access and usage policies and control, which is about to define all the policies around the access of the participants to the data services in the data space. In the second building block, identity management, we are proposing capabilities for making the onboarding of the participants in the data space by providing them identities and verifying these identities. And the third building block, which is about trust, is providing capabilities for verifying that the participant fulfill with the rules that are defined in the data space, and also to manage all the claims about the violation of these rules. And finally, in the third category of building blocks, we are talking about how to create value out of data, out of the services in the data space. And here we have 3 different building blocks. One is about data services and offerings descriptions, which provides rich, complete, and well-documented descriptions of all these elements that are in the data space, the data, the services built on this data, and the offerings provided through this data. The second building block is about publication and discovery, which is basically providing the cataloging features, in the sense how a data provider can publish their data into the catalog, and how an user can discover a data or a service in this catalog. So it's managing all the descriptions that have been provided by the previous building block. And the third one, which is optional because not all the data spaces are mandatory to have a marketplace and to monetize the data or the services, is the marketplace's building block, which provide all the capabilities for trade data and services, from the catalog management to the order management and after sales assistance and customer service. So this is the overall view of the building blocks. But if we want to set up a data space, we don't need only these building blocks, because these building blocks are just these functional pieces that are well, essential, like bricks for a house. You need to have these bricks in order to build a house, but you need also technology in order to implement these capabilities. And you need also to provide certain services in order to use these building blocks to provide the tangible functionality for the data space. So that's why we are also in the definition of these three services. One is about the registry of all the credentials of the participants in the data space. Also, the data space connector, which is the local deployment and implementation, concrete implementation of this building block that has been locally deployed by the participants in order to be on board on the data space. And finally, some federated services in the case that we want to federate one data space with another data space, and then to get access to data and services from one data space to another data space. So how to use this blueprint? Well, when possible, we propose to follow the same structure of building blocks that we are proposing here. And so then we recommend to do the mapping between your building blocks in your data space. If you are thinking in setting up a data space with the proposed ones by the support center, and then to identify what is missing or which is incomplete. So you can propose a specific building blocks for your domain. So you can use the support center building blocks and then complement with your building blocks. Or you can also provide building blocks that are relevant for all the domains. So you can come to us, and then we can study how to incorporate this into this building blocks taxonomy. And of course, to propose implementations, that is the next step now to go to the implementations. So just as a matter of summary, I would like to highlight that the data sharing is more and more demanding. Data spaces is an instrument in order to facilitate this data sharing. The Data Space Supercenter is providing the guidelines and the tools in order to facilitate this path. And we are providing certain assets, including the blueprint that I have just presented with the building blocks. So just go there, go to the website, look at it, and take it for your need. And just finally, to know that if you want support, we can offer support to you. You can also get involved in the co-creation of all these assets, and you can follow us in our monthly insight series and also in our next data space symposium next year. So this is all from my side, Flora. I think I'm more or less in time. So I hope that has been useful for everyone.
You are just in time. Thank you so much. It has been very, very insightful. It's already has created a discussion on the background and the chat.
I can imagine.
We will make sure to tackle these questions in the end of the Q&A session. So thanks a lot. And we will give the floor to Edward, who is today with us to explain further the challenges behind the research regarding to data spaces. So Edward, the floor is yours.
Thank you very much, Flora, and thanks very much for the invitation. Very happy to be here today. So what we'd like to talk about this morning, if I can get my slides to work, there we go. So what I'd like to talk a little bit about is some of the research challenges that we see here as well. So we are involved in the Data Space Support Center, but today's presentation is kind of taking this perspective more from what are the research challenges that we face, what are the obstacles that we face over the next couple of years as well. So maybe a more of a higher level perspective than what Clara has just given there, and she gave a fantastic presentation. What I'd like for us to think about is the challenge that we're actually trying to tackle in common European data spaces is actually very significant, and I believe it could be one of the kind of defining digital technical infrastructures that we'd have in our generation. It is literally a moment that big if we can be successful in trying to achieve this. And I think it's important to put that in context so that we understand where we kind of sit on this timeline. Here's an image that talks about, the web, and we know that the web was supposedly invented in 1990, and it went mainstream within a couple of years, very, very quickly. And Tim Berners-Lee done some amazing work there. But what Tim also did was he leveraged work that had taken place in the previous 30 years. There were so many things that happened before the web in order to make that web happen, in order to be able to make that web a transformational thing that effectively changed our society. And I think we should kind of take this longer term perspective as well when we're thinking about data spaces, because we are thinking of something as significant as the web in terms of its change to society. And we should think of the journey that we're on as being something that will be measured not in months or years, but possibly, a decade or two. And that's the kind of journey that we're in the middle of. This is something that was kind of captured in some of the work that we did in the Big Data Value Association around 2000, where we done a white paper that tried to look at the opportunities and the challenges that we had with common European data spaces. And we kind of looked at this 10-year time horizon. And what we identified, and this was a collective community exercise with industry involved, academia involved, public sector people involved as well. And what we identified was kind of different phases that we'd see. And we thought in the next 2 to 3 years, we'd see some kind of convergence between technologies and what we do. And I think when we look at things like the Data Space Business Alliance, we've seen that from a community point of view with BDVA, FireWare, Gaia-X, and IDSA coming together. We then thought after the convergence, you move into a kind of a deployment stage where things like standardization become important and experimentation become very relevant. And now we've seen those kind of initiatives like the Data Space Support Center coming to support that, in addition to the CSAs, but also great work by the Commission and Digit with CEMIC and Interoperable Europe now looking at data spaces and how they help to deploy them. But what I'd like to talk about is, if that's where we currently are at, what are those next generation data spaces going to look like? What are the technical challenges that are coming from, I would say, a research perspective? And today I am a research scientist presenting here. What kind of technology challenges do we see? And can, by understanding those tech challenges, can they actually help us to understand the differences between the data space and things like data portals as well? So when we start to look at the research challenges are there, again, from the Big Data Value Association and the PPP that was supported by the Commission, we had a number of projects that were looking at the different types of challenges that exist with data spaces: technical challenges, business and organizational ones, legal compliance, and things that are more regionally based. I show this slide here today from an open access book that actually came out based on this. It's available online if you Google just data spaces book. And what I'd like to focus on today is an area where I'm an expert. I'm not an expert in business models or legal compliance, but I spent a lot of my life looking at semantics, looking at decentralization and how you manage data at scale. So very much these kind of challenges we have around decentralization and the veracity and the trust that we actually have in the data within data spaces. And that's really what I'd like to focus on today, because I think that really gives us a flavor of how far we've gotten in this journey, but also the challenges that we have ahead. I think if we kind of step back and look at the challenges that we have in data in our society, what we really see is that the type of data we're trying to work with is an ever increasing content space. If you think about it, in 1990s and early 2000s, we had relatively simple databases. We modeled organizations and people. We had tables that maybe tens, maybe hundreds of attributes. They fit very nicely into relational databases, and that was very nice. But you fast forward to the 2000s, the 2020s, what you see is that the data models that we have are incredibly complex. They're very large. You're looking at thousands to possibly millions of attributes. And if you think of like a digital twin of a human, with all the different elements that go with that, you can literally have millions of attributes about a human, right down from their DNA to their preferences for what they eat. These are very, very complex, large data sets that we're working with. Very challenging to put those into a relational database. The other challenge that we have when we look at data sharing is that fundamentally this is a decentralized problem. different communities, different people, different organizations, different people in the same organizations have multiple perspectives on reality, all legitimate because they're coming from their own perspective and from maybe their own background. But that creates challenges. It creates ambiguity, vagueness, inconsistencies. And these are just natural things that exist with us as humans, and that is reflected within our data as well. So we need to think about that as we integrate more data. We have these challenges around different perspectives. What we also have seen in the last couple of years is the amount of multimodal data that we've created has exploded. And this is very much has been driven by the Internet of Things, the Internet of Multimedia Things, smartphones, cameras, video, social media, but also within our industrial processes, we start to see that, for example, within medicine, the amount of imaging that's available has increased significantly as well. And this creates wonderful opportunities for us, but this is not the type of data that we were trying to manage back in the 2000s. And the technologies that we have today to manage data need to consider multimodal data and all of the different types that it exists. And thus our data spaces will need to do that as well. Subjectivity. As more users create data, what we find is that there's different subjective ways of looking at the world, not only in how you conceptualize it, but how you describe it and how you look at it as well. And this is something that needs to be dealt with. So it's the same challenge that we have with decentralization, but also in how we interact with the data. What you actually see is that when people query data, they actually often have very subjective ways of asking about it. So for example, if I want to find a reasonably priced hotel in London or Paris, what's reasonably priced to me and what's reasonably priced to Elon Musk are very, very different things. So we need to think about that notion of subjectivity, that personalization of the person, of the individual, and how we use that when we interact with data and when we analyze data as well. So this is a big challenge for us, objective and subjective types of queries. What all of this means is that if you look at how data is changing and evolving, and you look at the technologies that we have to be able to manage that, we're constantly in this kind of Red Queen kind of scenario where we're kind of running as fast as we can just to keep still. We're creating new technologies. We're leveraging things now like AI and large language models and foundational models just to be able to try to cope with the new data that's been created. And this is a constant thing that comes from a research point of view. It's not something I think that will ever end within the near future, because as digitalization is increasing, as we're creating new types of data, more types of data for different parts of our world, we need new technologies to manage that, to analyze that, to extract value from that. And this is a constant thing that we have to do. And that's why it's important when we look at this journey of data spaces that we're going on, that the Data Space Support Center is very much focusing on things that need to be done today to get data spaces up and going. But we can't lose perspective of the challenges that we'll have in the next 5 to 10 years as that technology for data spaces needs to evolve, or as our technology for data management needs to evolve as well. How do we try and tackle this though? And there's a really nice analysis done by Halvey and Franklin, and this was in the relation to data spaces, where they looked at the challenges that we have with the control and coordination and the semantic integration that we have with data sources. And they had this very nice way of analyzing this in terms of what they call the administrative proximity. How much control do we have over our data sources? And semantic integration. What level of integration do we expect? And what's really interesting here is when you look at it from the example of, let's say, web search. So you have web search, the level of control that you have over those sources is actually very low. If you look at open data portals, you don't have much control over those sources either. You can influence and you can ask people to do something. You can ask them to export or sort of publish data in a particular way, but the level of administrative control is relatively low compared to something like a database management system, where you expect to have full levels of control and you expect to be able to have guarantees around things like consistency, data quality, etc. At the same time, when you look at semantic integration, again, for web search and data portals, we don't expect the data to be fully integrated. In the same way, when you look at a database, you do expect that to be fully integrated. And this creates basically this kind of dichotomy where web search can handle scale, database management systems can handle high levels of consistency and semantic integration, but it is difficult to scale it to the number of data sources. And we'll explore that a little bit. The question is, when we talk about data spaces, where do they kind of fit within this type of analysis? And I would say that that's something that is probably going to be unique to each type of data space. Some data spaces will have high levels of coordination and semantic integration. Other data spaces may be maybe more looking like open data portals and web search, where there's less levels of integration and coordination between them. This is something that each data space, I think, themselves will need to figure out over time, to figure out what best works for that community, for that collection of organizations that are sharing data. When we think of this, though, in terms of interactivity, this becomes quite important, because the notion of control and the number of sources that we have is very important for the technologies that we use here. So this is I would say, a timeline of interactivity for humans on the web. So when the web was kind of, we'll say, at its early stages in 1995, we roughly had 100,000 websites, and the center of our interactivity was Yahoo. And Yahoo was a structured repository where you had a taxonomy with different websites placed exactly within that taxonomy. It was human curated, and it was very good. It was the center of the universe for us at the time. It was a mind-blowing thing. Fast forward, literally 3 years later, the web went from 100,000 websites to 2.5 million websites. And suddenly Google appeared. And what was great about Google is that you didn't need to understand that taxonomy. You just typed in keywords and you got back a set of results. And what was important there is that we moved from having these exact results that we had with Yahoo to computed results with Google. So it was a PageRank. It was basically, these are our best interpretation of what your search query was. That was very effective. It was very useful for humans, and allowed us to be able to navigate the web quite effectively. Fast forward about a decade, the web went from 2.5 million websites to about 700 million websites. And what you found is that actually humans were less interested in finding a website where the answer may exist, but actually they were more interested in kind of getting direct answers or information that could help them answer directly within their search results. So what you saw there was the emergence of the knowledge graph and these knowledge panes within Google. So you moved from having the approximate search results to also having these exact curated results that came from the Google knowledge graph as well. And this is the primary paradigm for interacting with large scale data today. What we've seen in the last 12 months is probably the start of a game changer as well. So suddenly we've got ChatGPT and large language models, and now we've moved from search and from knowledge graphs to conversations with large amounts of data. Today the web is about 2 billion websites, and ChatGPT has access to that. Is it approximate results? Are they hallucinated results? I don't know. We're going to find this out, but I think we're definitely at the start now of another change in how we interact with data at scale. And it's moving from even asking questions to asking for things to be created for you, asking for content to be created. And this, I think, will fundamentally change the way how we interact with data and do our work with large scale data. What this actually means, and what's quite interesting with this, is that the notion of good enough information means that if you're trying to create, for every business decision that you have, some of those decisions require perfect information. So for example, if you're flying a plane, if you have an autonomous car, these are life critical situations. If you're diagnosing a patient, you need very, very high quality data. However, for many decisions that we make, you don't necessarily need 100% accuracy in your data. Possibly 80% accuracy is enough. And this was a message that was given by Pat Hallen from Microsoft at the time, that talks about if you have large quantities of data, sometimes a good enough answer is sufficient to be able to progress with what you want to do. And this is an interesting notion, because very much this is how Google has been able to deal with large quantities of data that is loosely coupled, that's not closely coordinated. So it's an interesting paradigm to explore from a research perspective. Thinking of that longer perspective, there's lots of discussions about what the definition of a data space is. I'm going to throw in the academic definition that came from 2006 from Halvey and Franklin, that talked about the opportunity of data spaces not necessarily being a data integration approach, but more of a data coexistence approach. How do you make it easier for data to coexist together and not try to integrate it? I think it's interesting to look at this, because data spaces, as you say, we're on a long journey. And if you look at the equivalent journey within databases themselves, like SQL was only standardized in 1992. The Cobb theories for relational logic would have been from the 60s and 70s. It actually took us a long time to do that as a community. Hopefully it won't take us that long for data spaces, but it is useful to look at these notions of coexistence as opposed to data integration from a research perspective, from an opportunity to explore. What that really means is that the key things that we need to try to enable data spaces from that Halvey perspective is that we need to make sure that we support different formats of data, that our systems do not subsume the existing systems that are there, that we're working with the data where it exists and helping that data to be shared and to be worked with. That we use things like best effort and approximate results, so computational results, the equivalent of a Google search or a ChatGPT, to be able to interact with that data because it's low cost in terms of integration. However, there's a trade-off in terms of quality. And what's important is to be able to provide pathways to improvement. So you don't necessarily want to have to integrate all of your data sources, which might cost you a significant amount, but how do you slowly improve that semantic integration over time? So, slide is gone. So basically what this means is that if we look at the long tail of data that we have, so basically not all of our data is used to the same frequency. We have a lot of data that's used quite frequently, people-based data, medical records in terms of healthcare. But what you find is that there's an awful lot of data that exists in this long tail that we don't necessarily use on a frequent basis. And what we see is that traditional technologies find it very difficult to work with that long tail. Possibly these more computational approximate-based approaches give us techniques to be able to work with the long tail in a more low-cost manner. And this is basically the premise of some of the technologies that we're now seeing, and I'll talk about next. So the idea is that when we're building our support services for a data space, what we can look to, in addition to the things that the DSSC is looking at in terms of concrete building blocks for data spaces today, we can also look at the future opportunities that exist for this more approximate, more incremental approach to data management as well. And that opens up interesting opportunities, particularly when you start thinking of the lessons that we've learned from the open data community and the notion of the 5-star principles that came from Tim Berners-Lee. The idea of making data available easily at the start, at low cost, just releasing data, and then over time, increasing the level of maybe semantic integration or coordination between the data sources, following like a principle-based way. And like Tim Berners-Lee's 5-star method very much kind of follows that, where 1 star is very basically data has been released, 5-star data is fully integrated with a single schema. It allows for consistent search and querying. And I think these are the types of principles that we need to look at as well to help us manage large-scale data sharing projects as well within the data spaces. So when I look at, I suppose that's kind of setting the scene for the opportunities. What I think I'd also like to talk about very briefly is, well, what's actually happening in the area of research topics now that are probably quite interesting to look at as well. And these are all kind of live, active areas of research. So one of the main areas is looking at this blending of neurosymbolic approaches. So you have these deep learning models, and we also have things like knowledge graphs. And a lot of work is now looking at how do you bring these worlds together? How do you bring the statistics of neural networks with the semantics and symbolic knowledge that exists within knowledge graphs? And there's a lot of different ways of representing knowledge within the area. Everything from knowledge graphs, but you can actually find other types of logic that you can actually leverage as well, like propositional logic, first-order logic, programming languages. All of these can be fed into language models as we're seeing today and can be leveraged to understand these some symbolic logic and then merged with that, then basically merged with neural networks. Here's a very nice paper from Wang that talks about different ways of blending these knowledge graphs, symbolic models with neural networks. And this is a very, very interesting and attractive way for us to be able to do it from a computer science AI perspective. What I'd point out is one particular trend that we're seeing right now is this notion of foundational models. And foundational models are very much looking at how do we use large repositories of data to build foundational AI models to help us do things. And that's what I'd like to talk about in a little bit more detail, because I think there's a very interesting connection there with data spaces. In terms of foundational models, a very good paper that came out from Stanford looked at these opportunities and risks that exist with them. But basically, foundational models are looking at how to use a broad set of data that can be adapted to do different types of tasks within AI. This is an example of that. So we take all our data, images, speech, all of this data, create a foundational model, and then using that foundational model, we can adapt it to do different types of tasks downstream, such as question answering, information extraction, information captioning. This is quite interesting because in the context of a data space, I believe there's a very symbiotic relationship between a data space, which can provide high quality data, it can provide a community of users, it can provide data governance and compliance, it can provide training data for foundational models. The foundational models themselves can provide enablers, support services for the data space for us to be able to have faster innovation cycles, to extract knowledge from that data, to be able to tackle that long tail of data as well, and also to be able to provide different types of interaction models. So think of that ChatGPT kind of interface sitting on top of a data space, and you've been able to ask questions of your data space and then ask it to be able to create reports and analysis based on that. Obviously, what's great about a data space is that things like data quality, compliance, governance are things that ChatGPT doesn't have today. So there's this great opportunity, and potentially there's a basis there of a sustainable business model between data spaces and foundational models. So finally, that's a very high-level representation of that. I see I'm a little bit short for time, so I'll jump past this. But the basic notion there is let's use data spaces to train foundational models and then adapt those foundational models to specific downstream tasks that help us work with the data space, to use the data space, and empower the users to be able to work there. Very quick examples of that would be the notion of images, where we can create scene graphs from those using foundational models. And ultimately, those foundational models can be adapted to do things like question answering over images or multimodal streams, or things like image captioning. So very simple examples of that, but there's papers there that can be referenced and people can dive into that at a later point. And that's it from me. Basically, I think there's a massive opportunity for us to think about data spaces, the future research challenges that we're going to have. Semantics have never been more challenging because of our world creating more and different types of data. And I think looking at things like neurosymbolic AI, foundational models, large language models, give us some really interesting opportunities to be able to explore and work with data spaces and to really leverage the benefits of them. And I very much believe there's a symbiotic relationship between them. Thank you very much. I'll pass back to Floria.
Thank you so much. Thank you so much, Edward. It was so interesting to also get more information behind the scenes, more on the research side of data spaces. So thanks a lot for your time. The discussion is further developing in the chat, so we're looking forward on the Q&A session to further address the questions. So moving on, last but definitely not least, we do have Alexandra with us. Alexandra will give us more information regarding the CEMIC specification, services, and trainings in support of the data spaces. So Alexandra, the floor is yours.
Thank you very much, Flora. Thank you for the invitation to participate in this webinar, and also thank you to everyone for joining. I'm going to talk today about CEMIC specification, services, and trainings in support of data spaces. I am part of the semantic interoperability team and the interoperability unit at DG Digit. And in my presentation, I will first talk about the policy context. Afterwards, I will be briefly mentioning the role in services in general from DG Digit in support of data spaces. I will focus mostly on the semantic interoperability services and assets that we can bring forward to support data spaces. And finally, I will share with you where you can reach out to us through a single entry point to find out more about our specifications, models, trainings, and all the elements that we have at CEMIC. So why are we and how are we supporting this policy context? In Europe, we see already, but we are going to start seeing more and more that our digital future will be enabled by a data-driven economy and the use of artificial intelligence. In Europe, we are aiming very much at doing this, fully respecting our EU values and regulations. In this context, of course, the public sector also needs to become more data-driven. So in this context, it will have to improve its capability to develop policies and services through the use of management and sharing and use of data. This is supported by three main pillars. in our view. So the first pillar is the European data strategy, which aims to create a single market for data through a common European data spaces that benefit from common standards and interoperability protocols. The second pillar is the AI legislation and coordinated plan that aims to foster the development in the use of AI in Europe, highlighting the public sector as a trailblazer for the use of AI. And thirdly, the Interoperable Europe Act, which is now proposed and which we hope will be approved soon, which complements the EU data and digital policy landscape on data availability and data exchange from a public sector angle. The novelty and the big contribution of Interoperable Europe Act is that it implements interoperability by design and fosters the sharing and reuse of interoperable solutions in the context of public administrations. So in this context, our role as DG Digit, so the Directorate Informatics in the European Commission, is that we are ready to support data spaces with existing assets and services. And we are also looking forward to establishing synergies with the stakeholders that are active in this field and in order to provide a more comprehensive support. So we have different communities that we have around our different data models and specifications. We have different assets and services supporting interoperability, data analytics, trust and identity. And we are looking forward to supporting the data spaces by putting forward and helping with the catalogs and the metadata that we have, the data models that we have, the assets and services that support trustworthy data exchange, as well as our consultancy and our pilots. Going more in depth into the semantic interoperability models and specifications, we, as semantic interoperability team, have as goal to deliver pragmatic support to help build an interoperable Europe. And how we do this is by four main components. The first one is the specification. So what we do is publish and maintain an open and free to use data models with regular updates. The most known of these being DCAT-AP. The second pillar are the pilots that we are developing. At different stages of the development of novel solutions, we are working on specific solutions for public administrations to scale up their interoperability maturity. And we do this when they're asking us to, or when we see an opportunity to contribute, and we reach out. The third pillar is the toolkits. So we provide an accessible European toolchain for data extraction, transformation, and loading in support of making services more interoperable. And the fourth pillar is the knowledge hub. So we provide training materials, guidelines, and we organize events in order to foster interoperability and share knowledge of its benefits. Going more in depth, so the CEMIC specifications enable interoperability in different ways. So the first way is by making data transparent and available. Secondly, it's by supporting coherent implementation of laws and policies, helping implementing cost efficiencies, and by helping digitization and harmonizing processes. The most well-known examples of CEMIC specifications are the CEMIC core vocabularies, which are reused in various implementations and extensions across different domains, for example, from Inspire regulations to national data sets. We have application profiles, which are also very well known and widely used, such as DCAT-AP. DCAT-AP is a standard model model that to describe data catalogs, and we know that at the Open Data Portal, DCAT AP actually is used as a standard data model. We have also DCAT AP is always evolving. We are working now on version 3.0, but it is also extended and made available for different specific domains, such as statistics. There is a DCAT AP for geospatial data. There is a DCAT AP for base registry, so BREG DCAT AP. Regarding zooming into DCAT AP, DCAT AP's objectives are to support the discovery and access to data in a cross-border and cross-domain environment by describing metadata to be harvested across a distributed network of portals. DCAT AP, as many may know already, is based on the data catalog vocabulary from the W3C, so it's a standard model. And it helps to express constraints and usages on DCAT properties and classes, as well as includes additional properties and usages of controlled vocabularies. There are different domains of applications, such as open data portals, and we know about the open data portal at the OP, also base registries, and we are also now working on extending DCAT AP to machine learning models, to describing machine learning models into this new version called ML DCAT AP. Regarding data spaces, DCAT AP, now we have just had a webinar on DCAT AP version 4 data spaces a few days ago. And we can also share the link to that specific webinar. What we have seen that DCAT AP specifically tailored for data spaces can make a significant contribution by connecting data catalogs of data spaces. Stakeholders that we have discussed with have shared their interest in it for several European data spaces. Examples include the mobility data space and health data space. There are a series of events coming up on DCAT AP, such as the working group webinar on the 7th of November, and there's the working group webinar on technical issues. We are going to also release a new version of DCAT AP very soon, and we are working on training material on specifically DCAT AP for data spaces. What are the benefits of the DCAT AP ecosystem? So on the one hand, it enhances the findability and accessibility of data. It enables data spaces to make data catalogs findable. So it is made possible to have a harvesting network. DCAT AP also comes with a decade of experience of documenting, maintaining metadata records, and sharing through harvesting. It enables data spaces to express their metadata in a common language. It provides tools to validate the implementation of data. And finally, it provides a collaborative environment that allows data spaces to express their needs and additional requirements. So as we have seen, DCAT has been extended to different domains and contexts. So we have seen that it is easy to actually extend it by adding additional requirements and constraints. Regarding the second pillar through which CEMIC can support data spaces, we have implemented and we are in the process of implementing various pilots. These pilots are small projects aimed to showcase the value of new approaches and ecosystems. We have implemented a pilot using artificial intelligence and in support of semantic interoperability. And we have seen already also in Edward's presentation how important artificial intelligence, but especially natural language processing, so semantic analysis, can be in support of semantic interoperability. And here, because in CEMIC we have all these specifications, and we already have the important data models, we would like to integrate the power of natural language processing models, especially large language models, in support of aligning different data models, extracting metadata, and working on different ways to enhance and simplify the work of creating, for example, data models by using artificial intelligence. Other pilots that we have done or are in the process of doing are regarding linked data event streams. This is a new data publishing approach, and we have had a successful use of LDS by the European Railways agencies that has deployed a solution based on this linked data event streams technology. The advantage of this technology is that it is a publishing strategy in which a data provider allows multiple third parties to stay in sync with the latest or historical versions of the data source in a cost-effective way. So we only updates are made on a core version of data, but you can see the changes as the data is being updated. So you always have a knowledge of what has changed, and having a historical trace of how that has changed. We have also developed pilots in personal data spaces, and also Wikidata and Wikibase. And we are looking forward to further extending these pilots under new cases. Zooming into LDS, which is one of our latest pilots, and something that we are working to bring forward to not only the agencies that are working with data that needs to be updated quite frequently, but also with member states who could use this in various circumstances. We have as use cases a replication of data, syncing, and growing the collection of objects. What is our role in LDS? We see that LDS is a collection of immutable objects, where data does not change in itself, but simply new data is added to the stream of data. That helps to have up-to-date data, but at the same time be aware of the changes and accessing historic data in a very easy and straightforward way, while relating current data, so what is happening at the moment, with historic data. We are now working with various member states and organizations to help them publish their data in a manner that ensures the interoperability using LDS, aiding in implementation of pilots, development of the strategy and roadmap, and sharing of knowledge. The third pillar that CEMIC can support with in the context of data spaces is our knowledge hub. We have the CEMIC Support Center, but which will also become Interoperable Europe Support Center very soon. We are acting as an enabler, exchanging experiences, good practice, and insights on semantic interoperability and interoperability at large. We have experience in exchanging and building consensus in different communities, organizing webinars, workshops, and other events. And we are looking forward to welcoming you to our upcoming conference, CEMIC 2023, which will be in Madrid on the 18th of October. You can also join the conference online. And I will also share the link in the chat. And we are also having this year, as a big novelty, 3 pre-conference workshops, which are specialized, very technically focused. One will be specifically on large language models and semantic interoperability. And the second one will be on digital ready policy making. So interoperability, semantic annotations to ensure digital ready policy making. And the third one will be about a EU-wide inventory of data models. Within CEMIC, we also provide online training materials, and we have the EU Academy, which is publicly available. There you can find a lot of training materials developed by CEMIC on core semantics, DCAT and DCAT AP and its different extensions, and also other different solutions for public administration. And we also are providing guidance. So whenever you need to implement any of these specifications or models, we are here to help you if you need further guidance in implementing this. There are other trainings with relevance to data spaces, and here you have an overview. You can we're looking forward to supporting you if you need to implement any of the specifications or data models. And if you see that you would like to extend, for example, DCAT AP, we have seen that for the mobility data space, colleagues have worked on extending DCAT specifications by themselves, but we are also supporting them in the process. So we do extend DCAT to different domains and other applications, but we also have other groups that are extending DCAT AP with our guidance more on their own. So you can reach us through the CEMIC Support Center, and you can, on the CEMIC Support Center, you can find a lot of different resources. And now we have actually gone through a process of restructuring the information. So you find step-by-step support on starting from trainings to examples of implementations, to best practices, and also the support of a community that has a lot of experience in using the specifications and models and expanding them. So with that, I thank you for your attention and look forward to any questions that you may have. Thank you.
Thank you. Thank you so much, Alexandra, for your presentation, and thank to all of our speakers today. The discussion is continuing in the chat, and I think it makes time now to jump directly to the Q&A session. So in the meantime, I have already seen that, Clara, you have replied to some of the questions, but we have a few more to tackle in this time. And I will start with a question that, if I understand, is referring both to you, Clara, and also to Alexandra. What is the role of CEF digital building blocks in the context of data spaces? Would be happy to hear the reflections from both you ladies. Maybe Clara, you can start first.
Yeah, well, I did already my answer in the chat. The CEF building blocks have been proposed as one of the recommended reference implementations of some of the building blocks that we are specifying in the Supercenter. So, I mean, they are not disconnected at all. So they are specific implementations of some of the building blocks, EID for identity, e-delivery for devaluation. So, I mean, there are different reference implementations that will be referred at the support center, and one of them are coming from the CEF building blocks. So this is the relationship in my view.
Thank you. And I don't know, Alexandra, if you have something to add on this from your side.
I think Clara explained it very well already. So we do have in the interoperability, in the whole directorate, we have different solutions that can support different blocks in the data spaces blueprint, and they are suggested as alternatives in the list of existing solutions by the DSSC. So we're happy to support if the stakeholders decide to take these solutions and apply them to their data space. We're happy to support in their implementation, of course.
Yeah, I think it's partially related with one of the questions at the end about the relationship between CEMIC and the DSCC. Just for information of the attendees, in the process to collect the different standard specifications and reference implementations that are out there for the different building blocks, one of the contributors to this collection is the DGT unit. So we have included in this recommended somehow standards and implementations many of the standards and building blocks that Alexandra has just mentioned in her presentation. So they are somehow related and incorporated. So it's not, as I said at the beginning, we are not starting from scratch. We are leveraging what is already there.
Thank you both. And I don't know, Edward, from your sides, from the more scientific point of view, if you have something to add on this.
Yeah, well, I think I just kind of reiterate the point that Clara has made and kind of made in the presentation, is that there's an awful lot of work that's been done and there's progress that's been made, and it's just really important for us now to identify what are the things that we can leverage so that we're not reinventing the wheel. And that's very much something that's done within the DSSC as an open process as well. We've got our stakeholder groups, we've got our community groups, expert groups. It's something that we're trying to do in a collaborative way as well. So I think it's an open conversation, and it becomes important for us to build on those advances that we have, but also to learn the lessons from the things that didn't work 10 years ago or 5 years ago, so that we're not repeating those mistakes. Or if we are going to repeat them or try the same thing again, that we have some new knowledge or some new perspective on that, or we recognize there's a new technology that can help us to overcome the challenges from the past.
Perfect. Thank you so much, all of you, for your answers. I have more questions. I have one more question that is probably addressed to you, Alexandra. In which way it is possible for a Horizon Europe project that works on this topic to connect with CEMIC?
So we have a stakeholders community, and that can be accessed through the CEMIC Support Center, and we are available through there. We support different initiatives and different projects, not just member states. So the best is to contact us through the CEMIC Support Center, and we will see from there how we can support the project.
Thank you very much. And also, Alexandra, I think you have already sent, we have received a lot of questions regarding the trainings that you have on data.europa. I think you have already shared the links, but yeah, people are very, very interested on this topic. So that's something I would like to mention based on the chat responses that we have.
I'll share the links in the chat, and actually I think we are also we have trainings that were developed also by the OP on data.apa, and I think that there we have some upcoming trainings on data.apa version for data spaces upcoming in December, so that will be something to look out for in the following months.
Perfect. Moving on to another question related to you, Clara. I don't think you answered this question during the chat, but please do let me know. It's what is the difference between the technical building block and federated services, and why is a connector, which seems to be the most central technical building block, not a building block?
Yes, I left on purpose this because it's a bit long to answer by chat, so I prefer to do it by word. Well, I think that the first question regarding that federated services seems to be the same like technical building blocks. I think it's not the case. Well, first because of the nature of the building blocks, which is a unit functionality, is a software for a unique functionality. It's a basic unit of software. And federated services, we are talking about service, software service. And second, because in the one thing is, for example, the person that wrote the message put the example of identity management. One thing is the functional unit where you are identifying the participants in the data space and verifying its identity. And another story is the federated services that is allowing the federation of identities across data spaces, for example. So one thing is the unique module that each data space will have in order to verify the identity of the participants. And another thing is the service that is federating these identities across the different data spaces. So this is the difference. And also because the federated services can extend to different things, can extend to catalog, can extend to marketplace, and not only to identities. So, I mean, it's that's why we distinguish between these two. And similarly with connector, it's true that connector in the picture is somehow including all the building blocks, but it's not a building block per se. Again, because it's not a basic, it's not a unit, basic unit of functionality. It's a kind of implementation and deployment or of specific building blocks. Not all of them. You can have a connector with only, I mean, identity and trust, and not with the rest of building blocks. And also because the connector is a service that the participant has to deploy in its own premises in order to be on board on the data space. So the nature and the dimension and the scope of a connector is different of a building block. That's why it's classified as a service and not as a building block per se. So I hope that it's clear. So I don't know, Edward, if you want to add on top of complement the description.
I think you've done a great job, Clara. I couldn't add more to that. Excellent.
Okay.
Perfect. And I think we also have time for another question. I have a question for you, Edward, in the chat. It's quite lengthy, but I will try to do my best to go through it. So it's from Paul. Currently, we have the few developed foundation models are trained using data and information scraped from the web. One has to implement technical and contractual methods to protect one's data and information from being scraped. For datasets within data spaces, will it be possible to use those datasets to train foundation models? If so, will it be possible to prevent big tech getting access to these datasets? So that was the question.
That's great. No, I think it's a brilliant question, and it really gets to the opportunity that's here. So when we look at common European data spaces, there's two things at play here. One is the technical infrastructure that we have, but the other part of it, and probably the more important part, I think, is the regulatory environment in which it exists. So common European data spaces put both of these together. And what the European data strategy wants to achieve is to have owners of data, people that generate the data, being in control about how that data is used, whether you're an individual or a company. So a key factor for data spaces is this notion of consent. You're allowing your data to be used or licensed or reused, but under your terms and conditions, effectively, right? So this notion of usage control, and that's fundamental to the data strategy and data spaces themselves. What that means for foundational models is that me as a data owner, if I put let's say I put my data into the health data space, I put all my medical records there. The way I envisage it is that I should be able to say that, my medical data could be used to train foundational models that would help in the discovery of approaches for particular diseases, or to help researchers to do their work to try to discover cures. I could also choose to say, no, I don't want my data to be used there. Or I could potentially say I want it to be used by certain organizations. I want it to be used by national or European level organizations or research organizations. So I think what we have here is that the opportunity to allow users to say exactly how they want their data to be used, to give permission to people that want to create foundational models so they can do that or not do that. And I think that gets over this current scenario that we have, where effectively, if anyone here in the call or in the webinar has ever put a web page up or ever has their information online, that information has been used in ChatGPT today, and no one get permission for that. Now, we can debate the pros and cons of that, but what's great with Common European Data Space is that we are saying, actually, no, we're going to allow people to say how their data will be used. We'll have the regulatory framework for that, and that allows us then to create foundational models and other kind of models using the permission and the consent of the people that's there, which I think is a very, very positive step. And that's that symbiotic relationship that we identified. It's great to have that clear data governance framework for the use of our data with an AI models, whether they're foundational or something else.
Thank you. Thank you so much, Edward. I think we have tackled almost all of the questions we have received. We were very efficient today with our time, so thanks to all of you. And before closing today's session, I would like to take a few minutes. As I mentioned at the beginning, we would love to get your feedback on our webinars. So take a moment to scan the QR code and let us know what you would like us to include in terms of content, in terms of structure. So thank you very much for your time. We also have a lot of activities. As you have seen, October in Data Europa Academy is pretty busy. So we continue with a workshop on tailor-made for academia, for students and academics, on how to use open data for your research. It will take place on the October 19th, and we will have some representatives for universities across Europe to take place. And we will also have the final webinar on the Open Data Maturity Report of 2022, taking place on October 27th, focusing on the impact dimension. And definitely we are working on way more webinars and content that will take place throughout the upcoming months. Lastly, yes, another QR code. This time is for our annual survey. So we would love if you could take a moment also to answer to our user survey. We have it also available on data.europa.eu, our portal. So please do take the time to provide us your feedback on this. And I will close the session by staying on this slide and maybe some final remarks from our three presenters, our three speakers today. I don't know, Alexandra, Clara, or Edward, if you would like to have to say something as a closing remark.
Well, in my case, I would like to take all the notes and questions in the chat, because some of them are really interesting for us as a project. So please, if you can send us, it's very valuable material. Thank you.
Definitely do that.
Just from my side, very, very encouraged to see all the great conversation in the chat. And I think many very, very good points raised. And this is very much a collaborative effort. So we all need to work together, collaborate as much as we possibly can to make this vision come through.
Thank you, Edward.
And from my side, also appreciating all the interest, and we are looking forward to supporting with what we have currently in the CEMIC as specifications, models, trainings, and so on. But also looking forward to all the different developments. I think we live in historical times where we see data with so much potential. Obviously, there are also many pitfalls, but we are living in times where actually semantic interoperability and using data together from different sources to create things that are exceptionally complex and useful to support different big problems of the world can be a reality. I mean, through AI and all the different data from data spaces that can actually, I believe, become a reality.
This is so true. This is so true. Thank you. Thank you, all three of you, for your very insightful presentations. Thank you also to everyone joining and taking this time on this Friday morning to be with us. As mentioned, the recording and presentation will all be shared with you and be also uploaded to data.europa.eu platform. And see you on the next Data Europa Academy webinar. Thank you.